All right, let's get started.
Okay.
Hi, so today is December 13th, 2019, and this is our monthly Longhorn community meeting and our last one of the century. So congratulations on the marrying into the next, last one of the decade, not the century. Well, so today we are going to demonstrate our new volume expansion feature we have been working on for the last month. And also we're talking about one issue we have encountered recently. A lot of people asking about what's with the actual size versus the nominal size in the Longhorn. So I will explain that. And feel free to ask any questions afterwards. And also during the demo, feel free to interrupt if you have any questions or technical details want to be clarified. So here I'm joined by Shaw, which is our software engineer in the Rancher Labs, and he's been working on Longhorn for the last 8 months. And Shaw will give a demo of our volume expansion feature. Hi, Shaw.
Hi. Okay.
Yeah, so now I'm just going to, you can now start in demo and share your screen.
Okay. Now, okay. First of all, there are several prerequisites for this volume expansion feature. First, this Kubernetes cluster version should be 1.16 or higher. And second, the storage class we are using should set this field, this allow volume expansion field. And
yes, the reason we have to have that 1.16 is that before 1.16, the volume expansion feature using the CSI, which is our using the driver framework container storage interface, is still in the alpha stage. So it's not enabled by default. And in the 1.16 is the first beta release of the volume expansion, volume resize feature. So that's why we can only support it as natively on the 1.16.
Yeah, if the Longhorn detects that you are using 1.16, it will deploy this CSI resizer in your cluster. Then you can use, the Longhorn can use it for the volume expansion. Okay. For the last prerequisite, the PVC should be provisioned dynamically like this. We should use this kind of request to provision that PVC. Then we can use this PVC to do volume expansion.
Yeah, so basically you need to create PVC using the storage class, and you need to specify the size in the PVC. That's the standard procedure.
Okay, then we can get started. First, we can deploy a dynamic PVC and with his workload here. Now,
Sorry,
it's
can you
ready
make the
now.
screen a little bit bigger, because this is in the recording. It's
Okay.
probably will not want people to full screen every time. Yeah. Yeah, that's right. Yes.
That's fine. Okay. Okay. Right now we have a running pod here, which is using this dynamically provisioned PVC. You can see the size right now is 1G. First of all, we can log into this pod and write some data into it. Then we can do expansion to see if the expansion works fine. To simplify, we can we'll echo test1 into one file, then check if this file is written correctly. Okay, then we can edit the PVC to do expansion here by modifying this request storage in the spec. We can do expansion. Right now, we'll expand it to 2 gigabytes.
So as soon as you enter save and exit, the expansion will be in progress, right?
Yes. And you can check the expansion states by describe this PVC, you will see that, okay, there are some event for this following expansion. After it's done, you can see that the capacity of this PVC has become the latest size here.
Yes.
Then, okay, and we can check that.
How long will it take normally to expand the volume?
I think for typically it's no longer than 10 seconds.
Okay.
Yeah. Since it's online expansion, so I think yeah, you can use it during the expansion. And also we can check the volume state in our Longhorn UI. You can see that the size has become 2G here.
Yes.
Right? Then after this expansion, okay, we can enter into this pod to see, okay, if we can use the expanded part correctly. And now we will do DD.
Yeah, can we check the file is still there?
Okay. Okay, here is the mount point / data. Okay, we will see that right now the available size should be 1.9G, right? The total size is almost 2G. There's some, yeah. Okay, then we can use DD to.
Can we check the file? The file content is still correct because before we wrote the file, right?
Yeah. Then this test1 file is still here. Okay, the content is correct.
Yes.
Then we can use it to see if the expansion works fine. Zero.
Yeah, so what we're doing right now is we're trying to write a file until the whole disk reaches maximum capacity. So then we'll know that, make sure that it's not just the numbers you saw that, okay, there's being so many available, the more storage has been available. We make sure that is happening.
Yeah.
Yeah, so
Since
probably
we will write 2G data here, maybe we need to wait for about 30 seconds. Right.
yeah. So it should be pretty fast. So we also support offline resizing, and we're working on a way to provide the resize capability for the user with Kubernetes 1.14 and 1.15, which as well, but that probably not going to be very clean like this one, because in that way, the Kubernetes probably cannot know the change of the PVC size because the restriction of the CSI. But in the end, the actual size of the pod should be, the actual capacity of the pod still can be expanded. We're still working on that process.
Yeah. Okay. So this write is complete. Then let me check the actual size here. It's 1.9G for the new file, right? Everything looks fine.
Yeah.
And for the last step, we can delete the workload and recreate it to see if we can reuse this expanded volume.
Sure.
Then we can delete this part.
This is okay.
This part. Okay, it's detached now. Okay, the part is gone.
So because
then we
the
can
pod was done, the volume will be detached automatically by Longhorn.
Yeah. Then we can recreate it. Wait 4 seconds. Okay. Then we can re-enter it. First, we can check this mount point. Okay, still 1.9G.
Yeah.
And we can check the file. Okay, that's still there.
And still there. Yeah.
Yeah, and the content I think is right.
Yeah. Everything looks great.
Yeah, I think that's all for this online volume expansion demo.
All right. That's great. Thank you, Shaw.
Thank you. Okay.
And you can stop sharing your screen. In
Yeah.
fact, I want to share my screen. Let me do that.
Okay. Okay.
Okay. Can you stop sharing your screen?
Yeah.
Interesting. I do have some problem on my.
Zoom.
Oh, okay. I just installed the new OS, so it doesn't allow me to. Okay. Sure. Can you share your screen? I want to talk about the exercise one.
Okay.
Yeah, I just upgrade to the newest version of Mac OS X, and it seems the some permission wasn't set correctly. So
Right.
yeah,
Then we can.
that issue has been closed. So recently, this yeah, is it normal? Yeah. So recently, this many users ask what's the actual size inside Longhorn. So you can see the actual size in the volume detail page. Can you go? Can you go to the Longhorn UI?
Longhorn UI.
Yes.
Okay.
Click this. If you click into this volume, you can see that, oh, this volume's actual size is 1.98 G, right? And the size is 2 G. So, but if you, the actual size means the space used by Longhorn on the disk for each replica. So all the replica will always be the same. And if you have multiple replicas, the actual size might be bigger than the nominal size, which is 2G here, because replica stores the history data of the volume, right? So can you create a snapshot now?
Okay.
So after you create the snapshot, if you move your mouse into the snapshot, you can see that, okay, this snapshot is 1.64 G. And well, because when we create this snapshot, the disk was full, right? And the volume head itself, it doesn't have anything on that. If you move the mouse icon to the volume head, you'll say, oh, volume head is size 0. But at this point, if you are going to delete every file in this volume, the file system will tell you that, okay, everything is free, so there's about 2 GB space free in this file, in this block device. But in fact, as a block device vendor, we don't really know that. Because file system can just simply mark certain block as, say, as a file system, I know this block is unused. So I'm going to reuse that later, but it's not necessary to pass that information to the block device, that block device know about that. So this is another problem that people see, that if they create and delete a lot of stuff in the block device, and in the end, the size of the file system is probably only 1G, but the actual size of each snapshot and the volume itself is 20G. That's the different issue we want to address. We probably need to implement something like the trim command in the block level, just like the file system tell the SSD, like, I don't need this block anymore, you can recycle it. So we're investigate that possibility using on the iSCSI and see how to implement that. It's pretty complicated regarding that. Normally, the block device only grows, never shrink. So we are trying to see if we can save some space there. But in the end, the actual size you see listed in the volume detail is the space used by Longhorn. And if you want that to be smaller, you can delete snapshot. And sometimes, if you're looking at the right of UI, there's a show system hidden. And I don't think there will be any snapshot, right, as a system hidden snapshot now, but
No, there's one for expansion. for this one.
Oh, really? Okay. Yeah. So that's what the system hidden snapshot will be deleted whenever any snapshot was deleted. And because of the mechanism how Longhorn works, we always have to keep one snapshot after you starting creating snapshot. Because if you're still trying to access the data of the volume. So so that's about it. And another trick to clean up the snapshot automatically. So you can set up the recurring snapshot. And for every, can you scroll down? Yeah. So you can edit here and set up the recurring snapshot. Type is a snapshot. And the schedule you can do every day. And you can return last 2 of them.
Okay.
And click save. Yeah. So in this way, every day on the 12 a.m., the Longhorn will automatically create a snapshot and it will clean any other snapshot which are left before, which is most likely the system, at least the system hidden snapshot created by the like volume expansion, like rebuild will be automatically deleted. So that's the one way to deal with this if you want to preserve more space and don't worry about the history of the snapshot, the history of your volume. Of course, for retain your history, retain your volume data, just make sure you have the recurring backup scheduled as well. So you can also do that from here.
Yeah, we can add one more here.
Yeah. Yep. So if I say I want to which in the last 7 days, then we just last 1 week. To retain the last week of snapshot, you can just put 7 in the retain there. Yes, so that's fine. And you can set what time you want to make the snapshot.
Yeah.
Yeah, you can. Yeah, okay.
What happened for this?
You have to click in some minutes, it's every minute or specify minutes, and then click next.
Next.
Yeah. Yes.
No.
Yeah. So.
Sunday.
Yeah.
I think yeah, that's. Then I will click OK.
Yes.
Yeah, like this.
And you can set up the retain to 7 for saying that just keep the 1 week's snapshot, 1 week's backup of your data, and which are going to be done every day. Yeah, so that's all for today's demo and talk. So I see that if anybody has any questions and want to ask us as the developer or to want to know more about Longhorn, just free to let us know now.
Yeah, so hi. So
Hi.
I guess my question was going to be, when is the volume expansion going to be released?
So the volume expansion feature will be released within the next Longhorn release, and currently we're still planning that because the current situation is we're trying to get in the Longhorn GA as soon as possible. So we're probably going to have one release before the GA, and then the release, and then we do the GA release. We're still working on the plan right now. So I would say sometime next month or at most February. Yeah, I think most likely just this end of this month, or probably most likely just next month.
Okay, so your first priority is to get to a GA release for the current feature set.
Yes,
okay.
And we are trying to add as minimum some feature like volume expansion, and this because we think it's very important. Many users ask us for it, so we want to add volume expansion. There's probably some other features, but just make sure that the current feature set is stable and working towards GA with that.
Okay, and then so I can't remember. I was looking at it, but I can't remember. So for local volumes, does Longhorn use local volumes then for allocation? I think you have to have a file system mounted,
yes.
right?
Yeah. So if you look into the node, sure, can you move over to the node page and show the disk?
Yeah.
Yeah. So Longhorn need to have a files. Can you expand though? Expand. Yeah. So you can see that the path, this is the default path Longhorn is going to use. Of course, we're going to, you can add any other path you want. Just for us, it's just like adding multiple disks, but it's the file system need to be, the disk must be formatted and mounted as on the host so Longhorn can take it. At least that's the situation for now. Yeah.
Okay. Is there any thought about using local volume support?
What do you mean by local volume support? You mean the Kubernetes local volume?
Yes.
Not really. Yeah, because something like if we have this, because now for this disk here, we do have full control of it, and we know that how many spaces how many space has been used and what's the free, and also like something like we also have guaranteed that you're not going to use one disk twice at a different mount point. So we also record the file system FSID. So I need to see that how can he translate to the Kubernetes local volumes. But we are basically using the same thing here. The local volume use the storage on the disk, and the Longhorn also do that.
Right. No, and I understand that, and that makes sense. But it's, I'm trying to figure out how to manage multiple services across different nodes, and having one central way of managing the storage across them all is kind of interesting. That's why I was interested in the local volume stuff. But
okay.
Yeah.
So why want to use the local volume then?
Well, the reason is that in some cases, if you have a distributed database, it can use local volumes for the storage, right? And then if I want also regular storage as well, I could also use local volume. So I have one way on each node, basically, to manage the storage. Versus,
okay.
Right.
So, but in fact, for the Longhorn storage, the Longhorn is itself a storage system. So if you want to provision a Longhorn volume, you're not really going to use local volume, because that's a different stuff from.
No, I understand. I'm just saying, like, underneath all of it, right? So each of my nodes, right? Let's say I have an SSD drive.
Mm-hmm.
Well, I want to be able to allocate that some portion of the SSD drive to Longhorn, and then some portion of that to, let's say, Cockroach, right? As a distributed, database. And so now I've got one way of basically dividing up that SSD across the, two different services, with a local volume.
Yeah, but the local volume, I don't know local volume. I don't think local volume has the capacity limit there.
Yeah, there are people that are working on, adding things on top of it. There's somebody did a dynamic local volume provisioner.
Yeah, that's me.
Was that you?
Yeah, if you look at the, I think recently it has been added into Kubernetes in Docker, and Ben Elder add that, and also the K3s is also using that. You can, at least my version of doing that is in the Rancher / local path provisioner. But basically, yeah, so that's one part. That's probably the different versions though.
Okay. Anyway, so that was my questions. Thank you very much.
Oh, no problem. Oh, by the way, you can, if you want to, you can raise an issue on the Longhorn GitHub, and we can follow up and see that it's feasible to do so. But from this point, I think it's, as for the storage, it's probably a little bit hard to, for us to don't have a direct control, and based on, and also we can need to look at what's the limitation of the local storage, local volume feature.
Okay, thank you.
All right, thank you. All right, so I think that's all for today's meeting, and thank you for joining. And we'll send out this recording to the YouTube. And thank you everyone. See you next time.
See you.
Bye.
Bye.